Thank you to all the speakers from our first block of talks, Bryan, Vitalik, Irene, and Juan, for setting the stage for a great Q&A. I think our first question will come from me. It's from Joshua Topkin via Telegram, and he's posing it to Bryan Ford. Do you think using multi-party computation techniques like threshold signatures among a sampled cohort in order to source a random seed from a chaotic system, like weather data via oracles, can be used for blockchain systems? Is there a place for true randomness in blockchain security? Or are deterministic verifiable random functions, VRFs and VDFs, the only viable options?
Great, thanks. That's actually a really good question. There's a number of issues embedded in that. So of course, there are indeed many ways to do distributed randomness. DRAND, is one point that we haven't gotten to yet, but will come in a later talk. DRAND already uses contributions, original contributions from randomness from different sources. Each of the participants can choose to use, subatomic particles or weather data or picture videos of lava lamps or anything they want to produce, really good, high quality, true randomness and feed it in, right? Now, the big caveat, one big caveat in the DRAND protocol as it currently stands, using BLS signatures, this true randomness is only coming in once in a while at basically setup time, and each successive BLS signature is indeed deterministic, deterministically produced from the seed. Now, there are other protocols. In fact, a detail of the Rand-Howd and Rand-Hurd protocols that I didn't mention is actually those, instead of using BLS, they use Schnorr signatures. And in that protocol, there's actually an opportunity. It's a two-phase protocol. It's more complicated, which is why it wasn't which is why it was less attractive for DRAND, and it has other issues. But one of the nice things about using a two-phase protocol is there's actually an opportunity in every single round for each participant to inject new true randomness if they want to, right? So at the cost of increasing protocol complexity and and having to give up BLS for a 2 or more phase mere secret sharing protocol, we actually could very well use true randomness in every single round. But that's an engineering decision, and we would I think it's worth exploring in the future whether there should be a DRAND 2.0 or 3.0 or something that incorporates true randomness in every single round. And there's many other interesting potential ways to improve it later as well.
Thank you very much for that comprehensive answer. Remember, you can always follow up in the chat, although not directly to the speaker. The next question will be posed live from Marcel Jakic. And Marcel, are you ready? Are you with us?
Yeah, I'm ready. Can you hear me?
Yes.
Yeah, so hi, Vitalik. The question I was asking, one of the potential solutions for calculating the VDF function to generate randomness are asics for efficient calculation. And how would you see that to be a risk for decentralization, so that the asics, which are very specialized hardware, centralize Ethereum 2.0 to some extent?
Yeah, good question. And I think, first of all, like ASICs are inevitable, like coming up with a function that where even the sequential speed can't be sped up with ASICs seems to be close to impossible. In terms of the things that we can kind of do to engineer around that reality, I think I mean, first of all, like for example, the Ethereum Foundation is kind of paying for kind of manufacturing these ASICs, and the plan is to kind of try to distribute them as widely as possible. And the ideal would obviously be having an ecosystem where you have multiple manufacturers. And then the other thing is that like if you're really concerned, you can kind of tune up that advantage parameter that I talked about in the presentation, and basically just kind of have longer delays and longer timelines, and make the protocol secure against someone having an ASIC that's even like 30 or 50 times faster than everyone else.
We completely agree with Vitalik, and we are also participating in the work to produce this VDF ASIC, and we would love to distribute it as widely as possible. If we can do that, then there shouldn't be a concern about access to ASICs. If we can get a large network of parties making them, if we can distribute them widely, if they can be cheap enough, if they can be very close to the physical limit, then I think we'll all be much better off by having VDF hardware like that, and we're working together to make it a reality.
Maybe follow up, wouldn't the extent of using ASICs also again increase resource consumption, which is proof of stake consensus trying to combat?
It would, but you only need a few people computing the VDF, and so the resource consumption is probably bounded above somewhere in the low millions of dollars.
Still like a lot less than as it is today in proof of work.
Like there's no kind of way to compute a VDF much faster if you put lots and lots of money into it. So it's not like it's like a race where everyone just like keeps on throwing huge amounts of capital in.
Okay.
Thank you. We'll move on to the next question, which is from the chat, and it's directed at Juan and Irene. How do you see Filecoins randomness needs evolving? Do you expect the random beacon currently provided by DRAND to be sufficient in the long term, or will it need to evolve as well?
That's a great question. And it really depends on how DRAND itself evolves too. So we know that eventually Filecoin will follow in Ethereum's footsteps and get to some sort of sharding solution as well. We might just use the same one, we'll see. And we know that we will have different randomness needs, but perhaps the block times might go faster and so on. There's a lot of different kinds of engineering challenges that change once you target a properly sharded network. So we think, for example, one interesting thing might be that you might want to have shards that move faster, that are geolocated in some part of the network that can have a much faster block time, say sub-second, and if you achieve something like that in one small locality of the world, then you'll need a randomness source that actually can give you something like that. So we would need to think about how DRAND might evolve for that. Or potentially DRAND itself might evolve to incorporate things like VDFs. So we might see a new generation, as Bryan is saying, maybe DRAND 4.0 or 5.0 go and use VDFs itself in the protocol once these are widely distributed and used, right? So we're sort of hoping that we can build our work here with DRAND and the legal entropy and so on can serve as the foundation for this, protocol, internet randomness protocol that can be a public utility. And whatever the solution is to that problem, we should just kind of keep upgrading the system over time to provide good and high quality randomness.
Great, thank you. The next question is also from the chat.
Can I add just one quick? Sorry to interrupt. Yeah, I think it's a great question, and I think it's hard to say. It's basically almost impossible to say because it depends on a lot of things. VDF was mentioned by one. It also depends on how POREP, proof of replication, and proof of space-time research evolves. This is quite new. So the things that we have now are based on this time assumption. It's very important to have randomness and predictable. This could change. It's a really new field. So maybe that's another aspect that it makes it very hard to predict the answer. It's give a good answer now.
Great, thanks for adding on to that. The next question is from Telegram, from Ilya Sharabokov, and it's directed at Bryan. And Ilya asks, is there a post-quantum analog for BLS RSA signatures in terms of uniqueness properties for DRAND-like beacons? maybe at least the most promising approaches for that use case? For example, using lattices, isogenies, etc.
Yeah, that's actually a really good question. And unfortunately, I'm not the best person to answer that question because I'm not an expert on that, post-quantum public key cryptography, which is essential for that. My understanding is that all of the post-quantum cryptography approaches to cryptography, some of them might be able to provide the tools we need, but they're immature. I don't yet know of a way to use lattice crypto or these other schemes in the way we need to do this using true randomness. Now, there probably is a way. I think these new crypto systems probably just need time to mature. An expert on, a true state-of-the-art expert on these post-quantum systems might already know of ways, might already be working on them. I'm not sure. But yeah, it's a very important need for future work where I'm sure the problem will be solved, but to my knowledge, it's not solved yet.
Thank you. That Sean means that we have time for just a few more questions. And I will take another one from the chat. This one is directed at Vitalik. Does adding VDFs reintroduce some kind of the dynamics present in proof of work? Is it that people need to do an expensive long computation to move the chain forward?
Right. So I think as I kind of said a bit before, like the difference between VDFs and proof of work is that in proof of work, you can just always keep computing the function faster if you throw more money at it. And it is kind of a race, and it's also vulnerable to a 51% attack. So if an attacker does 51% of the proof of work, then you're kind of screwed. Whereas in a VDF, there's like with increasing money, there's only a very limited amount by which you can speed up the calculation, and there's no there's no need for kind of anyone to beat out the attacker. You just have to, and if the public just have to have a computation speed that's within a factor of n of the attacker. Basically the rewards for VDF computation can be set to be much lower, and kind of the amount of economic activity around the VDF is probably going to be much lower than it will be in mining, or than it was for mining.
Thank you, thank you. The next question, also from the chat, is for Juan and Irene. The question is, by choosing DRAND, you're introducing a dependency on an external service. Does that make Filecoin less resilient or more centralized?
That's a great question. Like I was saying in the talk, the way that sharding is, so let me address kind of the interdependence question. The way that sharding of blockchains is going is that most of these systems and most of these chains there will be kind of a dependency structure between a number of different systems. This is already the case in terms of dependence on the underlying internet protocols. Just people don't tend to think of it that way. All blockchains depend on BGP achieving good routing propagation through the internet. All blockchains depend on the ability to send messages to each other and so on. So we hope that randomness can just become this foundational protocol, just like BGP, just like DNS, and just like these other systems, that is just sort of fundamental and expected as part of the internet. And it isn't seen as sort of like this kind of additional dependency. Now there's a lot of work to get from here to there over time, and more parties need to get involved. It needs to we have to run the network for a very long time with very little to no downtime and so on. And we have to prove out all of the engineering challenges of actually running a network like that. But we hope that that's not going to be seen in the future. It's just going to disappear from slides because everyone will just assume that, of course, you have access to randomness, just like, of course, you have access to routing on the internet. That's just sort of a basic expectation. Now, the other question around centralization, think of the proof of work world where there are effectively very few large-scale mining pools. Fiverr. There are some networks that are very large that have on the order of 5 to 6 parties that together could collude and mount an attack. The DRAN network itself has many more parties than that, and we hope that over time that the League of Entropy would expand with more and more parties. So the DRAN network itself wouldn't be seen as, or we don't think it's centralized at this point, but there are a lot of different parties working together to produce it. And in the future, it'll get even more decentralized as more partners combine. And if you're worried about centralization in the League of Entropy, you should start up an organization and you should join the League of Entropy and help maintain the randomness. You should be part of the solution.
Okay, great. And on that call to action, we'll move to the next question, which will be asked live by Raul and Chai. Are you with us?
Hi, yes, Roland here. So yeah, to Vitalik for the random, right? So can we use some sort of error correction code to tolerate the no-show of the last actor V in? And also for Ethereum 2.0, will random become part of the native protocol rather than living in a smart contract?
So I think the challenge with any kind of secret sharing approach is that in order to actually have those kind of algebraic dependencies between the values that every participant will reveal, you would need to have like some kind of distributed key generation procedure between the participants ahead of time, which adds some complexity. And another kind of annoying thing about it is that it kind of degrades the security model, because it says that even though one participant can't attack the rando, it means that if you have k out of n participants, you can potentially attack the system for free. Whereas with a rando, you can't attack the system for free unless you have like literally 100% of the participants. So yes, it's going down that path is kind of a complexity increase, and security-wise, like increase in some ways, but decrease in other ways. And like we tend to kind of measure security more in terms of incentives. So the kind of the decrease part, where if you have a majority you can manipulate for free, is definitely a big downside. So basically, for those reasons, like I think VDFs are kind of just a better path to take. And yes, in ETH2, Randall and BVDFs are both going to be a part of the protocol.
Thank you.
Great, thank you very much for that exciting Q&A session. I think that was pretty thought-provoking, sorry. And I think we're about ready to move on to the second block of talks, which is all about DRAND and the League of Entropy. I'd like to thank once again our speakers from Block 1,